Hi folks, Mr. Vogt here. This is the determination of the universal gas constant, capital R. This was filmed on October 23rd, and this is for kids that missed or anybody that just wants to rewatch the setup. So here's the setup. We have a beaker full of water. We have a little piece of copper. We have a stopper that has a hole in it. Okay, and then we've got hydrochloric acid here, approximately 10 mils, and this is a 5 molar. We've got a squirt bottle, we've got a funnel, and here's what we're going to be reacting. This is magnesium metal, and if we mass the magnesium metal, here's its mass, 0.032 grams. Okay, and we're going to be reacting magnesium with the hydrochloric acid. So what you can do is you can write that formula out, and that's going to tell you the balanced coefficients within the balance or within the chemical reaction. So what I'm going to do from here is I'm just going to kind of put this here so that you can follow along with what I'm doing. So you've in your laboratory notebook, in your table of contents, you can just call this the gas law demo or the determination of R demo. And then once you have that set, flip to the actual page where you're gonna do the lab, and you'll want a very simple laboratory setup, okay? And I'll kind of zoom in and out so you can see what's going on. And then you're gonna collect some data, and then you're going to process the data and solve for R using the ideal gas law, PV equals nRT. All the resources from today's class are online on Schoology. You just have to look, and away we go. The other piece of equipment that you may not be familiar with is this. And if I zoom out a little bit, it looks like a burette, but it's actually called a gas tube. And the gas tube does just that. It collects gas. So what I'm going to do is I'm going to put this back in here and make sure that you can kind of see. Okay, so what I'm first going to do is I'm going to take those 10 mils of the 5 molar acid and I'm going to put them into the gas tube. So here comes 10 mils right to the bottom. There we go. And now what I'm going to do is I'm going to fill the rest up with H2O. So I'm going to start slow with my squirt bottle, and then once I've got a sufficient amount of water in, I'm just going to go ahead and fill it on up. And I'm kind of doing this fast just so that it doesn't take 30 minutes for you to watch this. Okay, and I'm going to fill it literally all the way to the top. And the goal is to make sure that there is no there is no air up here. So if you can see, I'm almost filled it up, and what I'm going to do is I'm actually going to take the magnesium metal here and I'm going to wrap it in a cage of copper. And the reason I'm going to wrap this up is because the acid is going to react with the magnesium, and we want to keep the magnesium kind of at the bottom. So let me wrap this up. Okay, and then I'll show you what it looks like. Okay, so there's that. And one more down here for good measure. Okay, great. So let me zoom in. Here's our cage. So the magnesium is inside. The copper's on the outside. So when the acid hits the copper, it's not going to react. But when it hits the magnesium, it will react. And the reaction will produce hydrogen gas. And the hydrogen gas is going to displace the water that is in my gas tube. So I'm going to affix this in here. And I know that on the screen you can't see it right this second, but bear with me, you will in just a second. You'll see what's going on. Okay, so let me wipe my hands, and now let me zoom in so you can see. All right, so here's what I've done. Now, there's the magnesium in there. It's caged in the copper. I've put it into the water. Now notice there's no air in here whatsoever. Okay, and let me zoom in. Oops, let me zoom in again. There it is. Okay, and I put the stopper in, and now the stopper, you can see there's a hole at the top. So when hydrogen gas is produced, it's going to kick solution or liquid out the bottom. Now, if I come all the way to the bottom, the acid, the 5 molar that I'm using, is actually at the bottom here. You can't really see it super well, but it's more dense than water, so it's gonna sit at the bottom for now. So let me bring this back here. And now we can get the reaction started. So I'm gonna take my gas tube, I'm gonna cover with my finger, I'm gonna cover the end, I'm gonna turn it upside down, and I'm gonna drop this into the water, and then I'm gonna connect it with my burette stand. Now let's see if I can get in here. Okay, now if we look really, really close, can you see all that swirling? That's the acid, which was more dense, which is now at the top, it's floating to the bottom. And so here we go, and we're gonna float it to the bottom, and let me readjust this for you here, and let's see if I can zoom in. Okay, now when that acid starts to hit the magnesium, we're gonna see a reaction start to take place. So we're just gonna let it sit for a second. And the acid, believe me, it is coming down. And, oh, okay, now we can see bubbles starting to form. So what's happening is the acid is breaking apart, the HCl, and it's reacting with the magnesium metal. The metal, the magnesium, it's in solid form. It is being oxidized, so it's losing electrons. And the magnesium is turning to Mg+2. And so in our product side, the magnesium chloride, it's a chloride, so it's going to be soluble or aqueous. So we have Mg and chloride ions floating around in solution. The hydrogen ions from the HCl are pairing together and forming hydrogen gas. Now, if you look where the hydrogen gas is going, the hydrogen gas is going up and up and up. Now, last bit, let me zoom in up here. Oops, let me get the camera where it should be. And the gas is gonna accumulate here. Now, in this gas tube, what we can do is we can measure the volume of it. So let me come around here. And once all of the magnesium has reacted, you see how now there's gas accumulating there. That gas is H2, hydrogen gas. And what it's doing is it's forcing the water out of the hole at the bottom. And by water, I mean the magnesium chloride ions plus water. So this is gonna continue to intensify, and it's gonna continue to produce hydrogen gas. Okay, until all the magnesium is gone. The HCl is in excess, so it's going to consume all the magnesium. Now, what you want to do is you want to solve for the R constant value. So I'm going to turn the video off in a second, but I just want to walk you through the last couple of pieces. So in PV equals nRT, if you isolate R, you get PV over NT. The pressure is going to be 101.92 kilopascals. You're going to need to convert that into atmospheres. You can do that online very easily. That's the pressure that the reaction is taking place at, the atmospheric pressure. The volume you will record just as soon as this reaction is done. And really what you can do is you can take any of the data. Maybe what you should do is you should take the actual data from your class. So talk to a classmate, get their actual data. Another piece that we need is the number of moles, and that's the moles of hydrogen gas that are being produced, not the moles of magnesium. So go moles of grams of magnesium to moles of magnesium, then you use your balanced equation to find the moles of hydrogen. Okay, so that gives you N. Then we need to take the temperature of the reaction, which is the temperature of the water, which is room temperature. I think earlier today it was 21.6 degrees Celsius. You're going to want to convert that into Kelvin units. So you will have NT, which is in your denominator. You'll have the pressure, which we already stated in the video, and then you'll have your volume, which will be measured in milliliters, but you'll need to convert that into liters. So your units for R is going to be liter atmosphere over K moles. Okay, and I'll leave you with this parting shot. Look where we are in terms of production already, okay? And down here, If I zoom in, you can see that reaction is taking place, producing hydrogen gas. Okay, cool. I hope that helps. Have a good one.